Okay, so today we are going to discuss about circle for class 10th. We are discuss about circle. Okay, that is for class 10th and the chapter is also the 10th chapter. So first of all, today what is the circle? So the property of the circle we will just draw one circle. The circle has one center point. So let's assume this O will be the center point. This R will be the radius. Okay, so now it is touching this point P. Okay, so what we will say, OP is equal to that R. R stands for here radius. Okay, now what we will say, let's assume we have another point like Q here and we will meet. So this will also R. So now what we want to compute here, QP is equal to, that is R plus R. Why this is R plus R? Because this is QO plus OP. Okay, this value is the radius, this is also R, this is also R, this is equal to the 2R. Okay, so till this point everything is clear. Now we will come into the circumference. So circumference is if a person start moving around this circle and come back to the same point from where it is going to start. So circumference will be, circumference of circle is 2 pi r. Okay, so this is in the form of the r. So let's assume this OP, this QP we will see, this is the diameter. So diameter is equal to 2r. So now I want to compute in the form of this r. Okay, so let's r is equal to d by 2 also. We can write like this. This is d by 2. So now what we are going to do here, we are representing in the form of d. So we write here 2 pi d by 2. Okay, 2 will cut to do. So this is equal to pi d. This is in the form of diameter. Okay, so the circumference in the form of diameter. Now we will come into the circumference of semicircle. Semicircle is, so semicircle, when we come into the semicircle, so let's we'll draw one circle. So this is the semicircle. Here this point is O. This is the center of this. If I'll just draw the virtual circle over here, this virtual circle. So this is the half of this one. So here we have P point, here we have Q point. So if a person start moving from this point, so let's assume a person start moving from this point and revolve around the circumference of this semicircle and reach at this point. So what we need to do, we need to find how much distance he traveled. So how we will compute? So first of all, circumference of a semicircle is half of the circle. So 2 pi r is the circumference of a circle. We'll divide it by 2 and then we'll cut. So the pi r is the circumference of this semicircle. So whatever the circumference of this semicircle, okay, so this will be the what we will say. So this is not the complete circumference, but we will say this is the distance traveled by the person when he will start moving from this point and reaches to this point. Okay, so when we compute the circumference of a circle, now circumference of a semicircle, so circle means we will start from this point and revolve with this point and come back to this one and reach to this point. So it means if I am adding here, how much we will add here? This 2r. So this will become the complete circumference of the complete circumference of a semicircle. Okay, so till this point that we already discussed in this one. Now we will start to our chapter. So in this chapter, what we are going to discuss about tangent to a circle. We are going to discuss about tangent to a circle. In tangent to a circle, what we have, so this is the circle, and the definition of a tangent to a circle is like a tangent to a circle is a line. So it means it is a line. It is a line. Okay. After that, another property, what is it? That intersects the circle at that intersect the circle at only one point. So it is intersecting this circle at point this P. So let's like AB will be the line that intersect the circle at point P, and the center of the center of this circle is O. Okay, so now let's we will write the definition of this one so that it will be a little bit more clear. So we'll write the definition here. So definition is a tangent to a circle. Tangent to a circle is a line. So what I am trying to highlight here, when I am drawing to a tangent on this one, so this is a line. So this AB is a tangent, this line that, now what is the property? That intersects the circle, that intersects the circle at only one point, that intersect the circle at only one point. So let me just highlight this one. So tangent is a, so first property is it is a line, and now what is its property? It's intersect the circle, it's intersect the circle at only and only one point. It's intersect the circle at only one point. So here this line AB is a tangent line, and this P is the point where it is intersecting to the circle, and this is the our origin of the circle. Clear till this point? Any doubt? Okay, so now we'll discuss about the tangent to a circle. Now we'll come back and discuss about some more properties. So let's assume this is the circle, okay. In this circle I am just taking one more line. So let's take one more line. So this is the line that is intersecting to the circle, and we will take another line. So we will take another line, this is also a line here. Okay, so this line, let's have the property of this line. This is line AB, and this line is C and D. Okay, so we'll point this one A, this is B, this is C, and this is D. And this point is intersecting to the circle at point P. At only one point it is intersecting. So this line AB, so we will say AB is a tangent line. AB is the tangent. Now this AB is the AB is the tangent that is intersecting at a point P. Now look at this line. So this line CD, this line is intersecting this point. So let's assume this is point X dash and this is Y dash. It is intersecting at 2 points. So there is one more term that we will say secant. What we will say? Secant. So that line SECANT, secant. So that line intersecting the circle at 2 points, line intersect at 2 points is called secant. Clear? Any doubt till this point? So, and one more let's when we are discussing about this one, so let's one more property we'll discuss. If we have a circle, so let's assume this is a circle, okay, and this time first I will take one point. On this circle. Let's take this is the point on this circle. From this circle I can draw only one tangent. We can draw. If I'll try to draw another tangent from this circle, another point from this circle, it will intersect the circle at 2 points. Okay, so only this circle, this AB will be the tangent. This C and D is not. This is not a tangent. So if I will take like this one, this is the tangent line, but this CD is not a tangent line. This is the secant line because it intersecting the circle at 2 points. And now one more interesting point is that a circle, a line that okay, let's have a few more properties. The property will be like let's we have one more circle here. We'll take one circle, okay, and consider one point inside the circle. So I'll take one point inside the circle. Any point you can take, any point. Now if I want to draw a line from this point, so I'm just taking a line from this point. So I'm taking another line like this, another line I will I'm taking like this from this point. So if a point collide inside the circle and any of the line passing from it is called the secant line, it's not a tangent. So we cannot draw any tangent from the point that is residing inside the circle. Clear? Okay, that is the point that we already discussed about that. The point is no tangent is so this is the, we can say this is the case 1. Case 1 is there is no tangent to a circle passing through a point lying inside the laying inside the circle. So what I'm trying to highlight over from this one, whatever the line, there is no tangent to a circle that is passing through the point that is lying inside the inside the circle. Clear? So this is the what we discussed. This is the case 1 that we are trying to discuss here. So let's discuss another point that we already I already communicated to you, that a tangent always, the point second is, so like this is the let's take again a circle. So this is a circle, okay, and if I draw a line to this circle, so if I try to draw this line is AB is the line that I am trying to draw from, and it is touching to this point at P. So the point is there is only one tangent to a circle passing through a point lying on the circle. So this is the point. If I have another point over here, and if I try to draw one circle, draw one line over here that is touching to this circle, so this is the tangent. So let's assume this is the CD. So this CD, so it is touching only and only one point. So the point case second is there is only and only one tangent to a circle passing through a point laying on the circle. So why I am trying this here, if you will see, this is inside the circle. Here this is the point is laying on the circle, and we can draw only and only one tangent we can draw to the circle. Clear? So now we will move to the next point. This is the most important point. That is the point before the third point that we are trying to discuss is we have, okay, let's have one circle again. So this is the circle we have. Now we already discuss about, we already take one point inside the circle, another point we will take on the circle. Now what we are trying to take, we will take one point outside the circle, and now I want to draw a line. That is passing to this one, so that we will draw one tangent. So let's consider this is the point. From this point I want to draw a tangent on this one. So if I want to draw another line from here, So that is touching to this circle. So if the same line, what the statement is this, if this is the point where it is intersecting, this O will be the point, this like P will be the point that is residing outside the circle, and if I'll draw a tangent, so like this PQ and this one R, and let's take this O will be the center of this circle. So let's say we will join this one as a center of this circle. So we know one property, any line that is passing, it will make an angle of 90 degree. Okay, so now we will have this point O. So our purpose is we want to prove this one. So how we will prove? So we have two triangles here. So let's take two triangles. So we will take triangle POR, and another we have triangle POQ. We have two triangles. Okay, in this two triangle, what we have to prove? We have to prove that this is equal to this one. This is our proof statement. What we need to prove? Proof is PR is equal to PQ. We want to prove this one. Okay, that we have to prove. So to prove this one, we will take in this triangle this one and this one. So first thing, this OR. What is OR? OR is the radius. Here in this triangle, this OQ is also the radius. We'll denoted it by R. So this is equal to R. This is equal to R. Another line is common in both the triangles. So we have OP, and here also we have OP. So let's assume this length will be L. This length is L. Okay, so this line is common, so it means it will be same. So now what we trying to say? So in this is a right angle triangle. In this right angle triangle, this is the base. We'll say this is the base. This is our perpendicular, and this is our hypotenuse. So we will apply the formula for this triangle. H square is equal to B square plus P square. This is the formula. So here also we will do the same thing. So this is our perpendicular. We'll take, this is B dash base, and this is hypotenuse only. So we will write here H square is equal to P dash square plus P square. Okay, so till this point, any doubt? So now I'm just changing it. So we know that H square, this H square is equal to H square. So we can put here B square plus P square is equal to B dash square plus P square. So we can cut P square to P square. So we will have B square is equal to B dash square. So this square to square we can cut. So now B is equal to B dash. So if you will see in this figure, what is B dash? B dash is equal to P R, and B is equal to P, and this one is the PQ. So this is our proof that this triangle, whatever the triangle we have, POR is concurrent triangle, and this is POQ. So that this side is equal to this one, this is common, and this is the radius. Okay, so what we prove here? So the statement, now I am just writing the statement. The length of the statement is the length of segment, of the triangle the length of segment of tangent to a circle, the length of a segment of a tangent from the external point this P, and the point of contact point of contact with circle is called the length of tangent. What we say, from this point we'll say the length of the tangent. So what is our property here? So the property will be, I'm just writing the theorem, the case statement here. So exactly two tangents to a circle through a point lying outside the circle. So what we said, the two tangents we are trying to download here, two tangents, this is the tangent 1 and this is the tangent 2. Exactly two tangents we can draw from this one, that is the point that is lying outside this circle, and the length of these two tangents is always equal. Okay, clear? Any doubt?